My name is Hal Sriver, and I am a senior solution engineer here at Unravel Data. For those of you who don't know Unravel, we're a data ops and FinOps industry-leading observability platform built for modern data stacks like Snowflake. In today's conversation, our topic is going to be right-sizing your data infrastructure, optimizing Snowflake clusters and configurations. So what you'll be getting out of this is I'll walk you through some of the ways that customers are attempting to right-size their environment today with out-of-the-box tools. And then we'll get a glimpse into how life could be better by right-sizing your data infrastructure with Unravel. Then we'll go take some questions and we'll break for today. So let's talk about how customers are trying to right-size their environments today. If you've been following my webinar and demo series here, I've been talking a lot about some of the Snowflake system tables, or those views rather, right? And the reason why I'm doing this is because it's really a great feature that Snowflake provides, which gives you a rich set of data so that folks can really start to understand what's going on behind the scenes of Snowflake. The other aspect of this that we've talked about throughout this webinar series, and we'll continue to do so today, is how Snowflake has brought in some of the cost metrics that are really important to everyone, right, to monitor and ensure the responsible usage of the platform. And there's actually a couple of other table views I'm going to call out today that are available to you in Snowflake. There's a lot, right? But I'm going to touch on another one today that I've not spoken about yet. But today we're talking about right-sizing your infrastructure. And so what I thought would be good is that we could actually go and take a look at a few optimization best practices and techniques, if you will, as provided by Snowflake. So first, and I'm providing the link for you here as well. Let me go click on this link and let's see and take a look at what Snowflake provides as some things to keep in mind, right? Some best practices, especially when we're talking about optimization in that standpoint. So there's a lot to consider with that, by the way, right? And there's a lot of information here in this documentation. I'm actually just going to start on this considerations kind of subsection here. And again, a wealth of information. So things like, hey, how are my credits being charged for the different warehouse types, which is important, right? We need to be cognizant of that. But scrolling down here, there's some other things. There's even recommendations around how the composition of your queries, your SQL queries themselves, impacts the warehouse and the processing that it's doing itself, right? And this prompts you to pay attention to all sorts of different things, but for one, maybe the overall size of tables, that's going to have an impact. Things like query filtering, the use of predicates has an impact as well, right? The number of jobs, joins rather, of those tables inside the query. Caching, right? Also very important. This impacts your queries as well. Now, keeping all of this stuff in mind, when you're creating your warehouse, a couple of the most important factors to consider are size, for one, right? And what does that talk about? It's the amount of available resources in your compute. But then how are you managing that? Are you doing that from a manual perspective, or maybe via some sort of automation as well? And then you got to do things like consider the number of clusters in your warehouse. That's an important factor as well. And I'm going through all this to illustrate a point, because at the end of the day, you still have to select your initial warehouse size after considering all those things that we just listed, right, and scrolled down from. But that choice has a lot to do with your task or your warehouse, and what is it running, right? How much data is it loading? what's your query actually doing? And a lot of the times we don't know exactly what that's going to end up looking like, right? So here in this tip box down here, this blue tip box, Snowflake recommends, hey, that we experiment by running the query in different size warehouses to evaluate, right? Okay, all of that is great in an ideal scenario, but the reality is we sometimes don't have that luxury. We set things at the largest t-shirt size we can that's available to us to ensure that our app or query runs, right, doesn't fail, and we meet our SLAs. Now, also, don't forget about keeping in mind things like other use cases around, maybe scaling up versus scaling out, plus other considerations around, I don't know, other configurations such as automating the suspension of or automating the resuming of those warehouse clusters. Okay, so that said, I did mention at the beginning a few moments ago that in previous episodes of this webinar series, again, if you've been following along, that there's some great native tooling that Snowflake provides, right? So they give you access to these system tables, to those views, things around account usage and information schemas themselves. So now what I'm going to do is I'm just going to jump down here to this subsection, right? Monitoring warehouse load. Now, in order to choose a t-shirt size in terms of our warehouse, we need to know if the actual resources being used are actually going to be enough. One way to figure this out is to look at query load as well as query performance. Again, ton of information here, incredibly useful information and best practices provided by Snowflake. But here in this page lies a tool we can use, a way we can help evaluate our warehouse query load. By the way, what is that, right? What is warehouse query load? It's essentially a measurement of the the average number of queries running or queued within a specific period of time, a specific interval of time. And this is something that we can customize, right? In terms of that period of time and that interval being set to evaluate the warehouse's performance. We can do that by actually querying this view, this query history view inside of the account usage itself. And this view is available in the UI. And by the way, there's a note here that you have to have specific privileges, right, on that warehouse to view those charts. Okay, great. But there's even different ways to view those charts, right? Through some other tools, some other dashboards, like Snowsight, for example, if you're using that, or maybe just the classic console itself. But Snowsight in some cases requires you to set up another warehouse to actually run your queries against in order to monitor and display something more rich than just having access to that metadata. All right, but let's say you did all this. You did all this work. You set all this up, and you're consistently and constantly tweaking that. Now you or somebody has to reference all of those, charts, right? Load monitoring charts in order to make a decision. And it does give us some clues, right? We also have to understand how query load is calculated, but it gives us some clues, right, as to monitoring maybe the performance of the query. Maybe its load is low in some cases, or maybe it's high in others. But we have to evaluate these patterns. We have to understand what we're observing and taking into consideration maybe the peaks and the valleys of that data, right? The seasonality of that data. Okay, then we have to extrapolate out the costs of things, right? What are the costs and credits associated with those usages between those different options, right? If we're evaluating how things run on different warehouses. And by the way, if your chart shows that your query is performing slowly or poorly, and you made a change to the infrastructure, but that didn't improve it, now what? Okay. So taking a pause here to pivot a little bit before I jump into this demo, and I promise we'll get there in a second. There's a few unspoken things here that I want to touch on and call out. all of this that I just covered does require somebody who knows what they're looking for rather, and knows what they're doing. Basically an SME, a subject matter expert, right? To kind of understand, hey, what are we trying to do in order to make sense of this data? All this data in all these views. That's on you. If you're using the system tables and those views, that approach, you'll need to then make sure that somebody who knows what they're doing will be able to actually create some kind of an actionable insight from all of that. And then you also have to create some of your own dashboards in some of these cases, right? And by the way, you got to do this also for your various personas. So, taking that use case from before of figuring out a t-shirt size, right, through monitoring load, that's just one aspect of it, right? That's great for a technical audience. So somebody who knows and can make a connection between the performance of your query and the infrastructure it's running on. And maybe that doesn't exactly tell me what that t-shirt size should be. You still got to figure that part out. But if I'm going to create all of these visuals, use the system tables and the views and so forth to create some dashboard, some report, those might not be digestible for maybe that other persona from a FinOps user perspective. Those people are going to care more about the cost side of the house, right? Because maybe they have a budget to adhere to, or maybe they're doing some kind of trend analysis and they want to see that mapped out in a dashboard in some kind of way. This needs to be created for that purpose. So again, a subject matter expert, an expert of some kind who needs to know these nuances in order to create these dashboards, from that perspective. So what I'm driving towards, which is probably the bigger statement here, is that a lot of this stuff still requires manual analysis. So someone needs to come in here, know what they're looking at, create these dashboards. And if you're trying to do this at scale, and maybe we want to identify, inefficiencies across all my queries, those could be in the tens, hundreds of thousands, right? All of my warehouses, all those apps, you're not going to get that out of the box. All of that will still require manual analysis from that Snowflake perspective, right? So in a nutshell, Snowflake system tables and views, right? Great way for us to leverage and use for some of these optimization use cases, but a lot of this stuff is not turnkey. There's still a lot of manual effort to set up, configure, to start getting some actionable insights with that system table approach. Now what I'm going to do is show you what life could be like if we're going to do those same use cases, but from an Unravel perspective. So here we're in my demo playground for Snowflake, and I'm starting here at this Home tab. Okay, and there's a lot of good information here. There's a lot of things you're seeing, areas for potential improvement, right? Around how do I increase my productivity from my warehouse, my query, my data perspective? Where can I focus my attention to reduce some of that cost wastage? And we'll dive into some of this here in a moment. Where can I focus my attention to improve performance? And we give you a lot of other good usage metrics here across the top, and other statistics from that perspective. And by the way, all these dashboards, these just start working out of the box from an Unravel point of view. There's no additional configurations needed. Now today we are talking about optimization. So I'm going to scroll down here to this insight analysis section, and I'm actually going to focus us in on our warehouses. And we have some reporting here. We have some dashboarding around warehouse specific insights. So, as an example, out of our 36 warehouses running in our environment that we're monitoring, we got 17 of these guys where Unravel has found some sort of underutilization, meaning the warehouse is underutilized because the workloads, the queries that are running on them, they're not utilizing the full extent of the resources available to them. So therefore, they can be run on smaller, cheaper warehouses without performance impact. So, what we're saying here is, hey, in the last 7-day rolling period of time, there was between, this $10,000 and $15,000 in wasted cost. Now, annualized, that's significant, right? Over 600 grand of untapped savings. And all we're really saying is that there are opportunities for both a consolidation and a right-sizing use case here, right? And so let's just dig into each of these. So from that consolidation, consolidated warehouses opportunity, that use case perspective, we're showing you the top 5 insights that we found or that were identified as underutilized warehouses, or a group of them that could all be consolidated into a single warehouse. So for example, just taking this top example, you could save over $500,000 if you were to take these 5 or 6 individual warehouses and rolled them all into one 4x large. Now let's look at the right-sizing use case. So Snowflake and data warehouses in Snowflake are very similar to interactive Databricks clusters, if you're familiar with that. If not, all that means is the cluster is just running. I'm submitting jobs, I'm submitting queries to my cluster. It's up to me to manage that, to regulate that, to turn it off, right? So the recommendation to right size from an Unravel standpoint is maybe to downsize, for example, from a medium to an extra small. And that's pertinent, right? Because most folks, they don't do the analysis up front to know if they should even start with that medium in the first place. So let me dig into one here as an example. Just again, I'll take the top one. So I'm sure everybody knows this, but just, for fun, in review, there's 2 different ways to scale warehouses in Snowflake, right? We've got the t-shirt sizes. We talked about this a little bit already. This is your scale up architecture. So for example, you've got a large warehouse, right? The large comes with 16 cores, some memory and so on. Or you got your medium, or maybe you're a small, right? Your extra small has 8 cores and 2 gigs. So when people think about scaling up, it's because they're running heavy workloads, right? They require at some point a lot of memory and CPU, because you're servicing your heaviest load, your heaviest query. Or scaling out. That's actually the auto scaling piece, right? Hey, I have 1 extra small warehouse, and then now at some point down the line, I have 10 of those extra smalls. It's really all about concurrency. Hey, how many users at once can I service? It's that, end of the year retail store during the Christmas time example, or it's the during the day, I got X amount of users on my apps, but then at night fewer. So fewer queries, less concurrency, right, from that standpoint. So now in terms of our recommendations for warehouse sizing, Unravels, we take in a lot of information. We take in things, considerations like idle time of the warehouse. Is it a virtual warehouse? What is that query load, right? From that perspective, we just talked about that earlier, right? In Snowflake's own documentation recommending we consider things like load. And we take in a lot of other telemetry data. It takes all of those things into consideration, the algorithm that is inside of our purpose-built AI. And all we're saying is, hey, did you really need that 5x large, right? Because if not, then make this change, because that equals less spend for you. It's simple, it's powerful. And here on the screen, we're giving everything to you on a silver platter, essentially, right, through this recommended schedule. So what are you looking at here? 7 days of the week, 24 hours in a day. The gray is the current configuration. This is what was chosen to be run by the developer or the engineer at the beginning. And the green is the recommendation. So Sunday 5x large. We did the analysis, and Unravel did the analysis and said, hey, yeah, this makes sense. Keep that 5x large. Maybe same thing with Monday. But over here on Tuesday, we noticed that you didn't leverage all of the resources in that 5x large. You can actually, there's an opportunity here to, if you just downsize, if you just chose a smaller t-shirt size for cost savings. And so we're giving you that here in a scheduled format where you can actually one click apply those recommendations, right? We're giving you that easy button. There's actually some code behind here. And we give that to you too. It's just a call to manage the tasks behind the scenes to actually make those changes on those t-shirt sizes, but we're giving that to you. Okay, so that's that example. Going back here to the home screen. Oh, one more thing. Let me go to the bottom. Okay, because you'll notice there's another section down here that we didn't touch on yet. This is that scale out use case. So we give you recommendations on minimum and maximum clusters from that perspective for your warehouse. So, and then here's some, unrealized, untapped savings. And oh, by the way, maybe some untapped performance gains as well. So we're giving you those recommendations as well. Now, what's not necessarily spoken here, so I'll just touch on this a little bit, is that Unravel has accelerated this whole process for you because that mean time to identify now goes down to 0. Why? Because we go ahead and tell you here in the homepage, here's where all those opportunities are to go look for or to go get and grab that cost savings, right? You're not going and looking for those opportunities anymore, or for performance tuning from that standpoint, right? Which also leads to dollars saved. And then guess what? The root cause also goes to 0 because we've done the analysis for you. Unravel, the purpose-built AI has looked at all of those things over time. It did that time-based analysis for you. Now, what about going and actually fixing it and then verifying it after the fact? Well, Unravel has already done the scenario-based analysis for you as well. So in the end, we're giving you a very good recommendation. We're saying, here's a recommendation to save costs without affecting performance and stability of your platform, right? All you need to do is go and make this recommendation. Again, it's that easy button. Now, if you think about all your different audiences too, maybe a technical audience would want to get a little deeper, more detailed. We have those reports and dashboards as well to give you the details as to why we made those recommendations. But now think about that FinOps team. We'll take that use case, right? Or from their perspective, the ones that are just trying to optimize their environment, but they don't know the technical jargon on how to speak to the Snowflake team, right? That's actually using Snowflake for maybe some Gen AI workload, right? That just as an example. So what this does, what Unravel does, it opens that door. It allows them, the FinOps team, to have that conversation to say, hey, look, Unravel is actually saying we could save this amount of money in this particular case. So why don't you at least go and click on this link, right? Click on this link here or wherever from that standpoint and make those changes. It makes the conversation easier. One other thing I'll mention, just to keep this in mind, I know I told you this is my demo environment. We want to keep our costs low here, and so therefore the data sets are small from what I'm showing you here. But think about this in terms of your environment, your queries, your workloads, right? You could be spending thousands, tens of thousands, potentially millions across the entire Snowflake estate. These savings all start to add up. And this gives us a great way to see enterprise-wide across all my Snowflake accounts, hey, what are some of those low-hanging fruits, right? What are some of those things that we can instantly realize from a cost-saving, kind of quick hit standpoint? Things like right-sizing a warehouse, right? Simply by making a change. What are those first wins as the operations team, who's getting pressured to reduce costs can have? Or maybe from that, FinOps team perspective again, hey, where can we actually enact and actually net out some sort of savings from that standpoint? Okay. Now I'm going to touch on another portion of the homepage here in the second tab related to queries. Again, under this insight analysis section here. You can think of this as that code level or that SQL query level insight layer. And here what we wanted to really capture is that further right-sizing optimization can be done if you actually go even deeper beyond the infrastructure piece, right, to that code level. So how is that SQL written? Is it written efficiently? How is that code actually playing out? Is it actually using all the resources? Or was there some sort of bottleneck? Was everything running on an oversized warehouse? So let me just pick one of these and I'll illustrate it through an example. How about inefficient join condition? I'm just gonna sort by a few things. Okay, and let me just go. All that did, by the way, if I can back up, all that did was bring us to this queries tab from the homepage. Okay, and it's sorted by, we can see a lot of different insights from that code level perspective, but it's sorted by that that inefficient use case around a join parameter, right? And I'm just going to sort by cost here and pick this top guy. I will open a few things up. A couple of efficiencies it found, but we're going to focus on the cross join. Okay, so here, what are we looking at? You can see that what Unravel found is that on line 47, right, there's a cross join. And we actually give you the SQL text here at the top. We can scroll down to 47 and see it. We can see that in line 47, right? Here's that parameter. But Unravel detected the inefficiency, right? Because here in this line, the cross join was used between two tables, Policy Hub and Snapshot. Now, by the way, for those that don't know, a cross join is, which is also known as a Cartesian product, right, is where all rows listed in one table, table A, for example, are paired with each row in table B, right? So the product of that join is an explosion of data. And you can actually see here, right, 380 megs scanned total across those two tables, but over 1.2 gigs written from that perspective. So all we're suggesting is, all Unravel is suggesting is to consider using an inner join instead, right? Now, there could be some business case requirement for this. We don't know what that is. Unravel doesn't know what that is. We only have the knowledge, right, the insight that this is typically an inefficient way to write your code, to write your SQL. Unravel doesn't know what the code is doing from that perspective. But we can actually reduce the amount of data that's being processed, which will ultimately have an impact on how long the warehouse is being used or how long the app is running, and that should reduce cost there. All we're saying is, all we're doing is bringing your attention to this, and we're doing this at scale, right, across the entire environment, so that you can say, hey, I knew about this, or, oh my gosh, I had no idea this was written like this, and in turn causing my resources, my warehouses, right, to be consumed unnecessarily in this manner, or maybe even cause my app to fail because this query timed out and failed down the line. So now, speaking of that, timed out queries, that is, I'm going to go back to the home page here. And again, we're going to scroll down and focus on queries. You'll bring your attention to this section down here. So failed and timed out queries, we're monitoring that for you as well from that use case perspective. Now, here, there's over 1,400 instances of queries that Unravel found over, again, that past rolling time period or period of time. And here's the potential, savings or wasted cost, right? Potential savings, also annualized. But here are the recommendations. We're giving you the links. to go right to those queries to troubleshoot, those failed queries from that perspective. Or maybe even opportunities to move those to a larger warehouse in order to perform in a more timely manner, right? To not time out in the first place. Okay, so just scrolling back up to the top here. Unravel is not just about providing configurations. It can go even deeper and look at the code itself. Whether that's the SQL or something else, Unravel is going to be able to go there a little bit deeper and identify what, like what line of code, what SQL statement is actually causing that inefficiency, and then, calling your attention to it so that we can further reduce cost from that perspective. Alrighty. Okay, so zooming out, let's just take a step back here for a second. At the end of the day, Unravel is actually looking at every single query, all your warehouses across all your accounts automatically, and saying one of two things: either yes, everything is optimized, right, ideal state, or hey, not so much, right? And the homepage is giving you that glimpse into the health of your Snowflake estate or environment. And this is where we want to take organizations, right? So that you have an automated approach to really understand where are those areas of inefficiencies, where are they? And really start to define an approach or a plan of action to ensure that, this very powerful data stack called Snowflake is being used in a more cost-effective and efficient manner. But then also getting the performance that you expect from, these, very fast modern data platforms. So again, today's topic, right-sizing your data infrastructure, right? Optimizing your database clusters and workspace configurations. I hope this gives you a good feel about how customers are doing this today, using those out-of-the-box tooling, those system tables and those different views, that sort of thing. I showed you how you can use a purpose-built data ops and FinOps observability platform like Unravel to really help, upscale your game, right? And really net out all of the optimizations in your environment. So thank you for your time. What I'm going to do here next is look at some of these questions over here and try to answer them. Okay. All right, question number one. What metrics should I track in Snowflake for efficiency? Okay, what metrics should I track? So really, what that comes down to is identifying, hey, where the inefficiencies are in the first place. There's really no one metric to track, I wouldn't say. If you're using those account usage and those information schema views and some of the other system tables that I've been talking about, because what those things provide us is the ability to observe, this telemetry style data, and then go and create, some of those dashboards and charts and things that I was talking about. But to then actually measure the impact, right, of that, you don't get that. Now you'll get that from an Unravel perspective. And so for folks looking to track efficiencies, we have those metrics out of the box. So you don't have to think about what you need to track first or second, or from a prioritization standpoint. Okay. Question number two. How often should I adjust my clusters? Okay, so I guess to answer that, let's just level set a bit here. The way Unravel works is that we're learning over time. We're learning from patterns from that workflow perspective. So we need to first look at and learn kind of the seasonality of your data, like I had mentioned before. Those ebbs and flows of those apps and those workloads, and whether or not they're consuming, actually those CPU requirements, CPU versus memory, or vice versa. So we need to be able to see that first, so that Unravel can then go ahead and make those recommendations to either right size those warehouses, you know, in that case, and then ultimately still take advantage of some of the native Snowflake features like auto scaling. So there's a bit of a learning curve that Unravel needs to go through first, and then from there, really just taking those recommendations and applying it as the next step. Okay, so one more question. All right, what is the most efficient way to manage my clusters? Okay, I'm just going to say it. We're a little biased here, right? So the most efficient way to manage them would be to leverage Unravel. So, but seriously, we've been doing this for a long while now. So for over 10 years, actually, with some of our other purpose-built platforms, for some of those other data stacks, like I mentioned Databricks before, Hadoop, you know, from those standpoints. So my point is that we've worked with, you know, also some of the largest Snowflake customers out there too. And the common challenge is that teams and organizations, they just simply don't have the time. They don't have the spare cycles to spend on these mind-numbing tasks of optimizing, of, you know, really troubleshooting, you know, the why of it, why their pipelines are slow, why their queries are slow. Unravel is purpose-built for this. It's your expert in a box. It's a machine that doesn't need sleep and doesn't make mistakes, right? And it's constantly learning. So that way, you as an organization can really invest your engineering and, you know, development resources in a more efficient way to create, you know, the best data products that you want to do. Leave the mundane stuff to the technology, right? Like to Unravel. So that you can really level up your productivity overall and get your data products to market as quickly as you can. Okay, I don't see any other questions here. But before we break, I'm going to share one other thing. I sort of accidentally gave you a preview of this slide. But you can go today and get a free Snowflake health check. Simply visit this URL here on your screen, right? We'll give that to you. So unraveldata.com/snowflake-health-check-request. Go ahead and check that out. It's free to you. There's no cost, absolutely no cost to do this. So I definitely recommend you try out the product, see what life could be like if you're using Unravel for your data ops and FinOps observability use cases. Again, my name is Hal Sriver. Thanks again. We'll see you soon on the next one.